And before I button this back up, I'll give you a quick overview once more on your power distribution center panel. You have your two main 50 amp breakers coming in, and you can see you have your red and black, which are your hot leads coming in from the shore power cord feed at the back of the RB. The big heavy white wire is your neutral wire, and it's connected to a bus. You want to make sure all of these wires are secured tightly. And then behind this bus wire, you'll see another bus bar with all the shiny copper wires connected to it. And this wire right here is the ground wire coming in from the back receptacle on the back of the Alpine. And there's a bus bar on the back side across here with a bunch of different shiny connections, bare wire connections connected. You want to make sure that all of those are nice and tight. And you have your various 15 and 20 amp breakers on both sides of your main breakers, and that's for all of your various 120 volt outlets and such within the RV. Over on the right hand side of your power center is your DC distribution center. The white lead coming in is your ground, and the black lead is your positive. And you can see you have 15 amp fuses all the way down, with the exception of the 20 amp fuse, which is for the furnace. On those of you that have the Dometic Alpine or Dometic Atwood furnace, this fuse is probably going to be black, and it's a resettable breaker that's known to give you problems. So if your furnace is not starting up, check that black breaker, pull it out, and put a 20 amp regular ATC style fuse in there and see if it will take care of your problem if your furnace isn't turning on. If you have any of these fuses open up, the corresponding red LED over to the side will light up and tell you that you've got a fault with the fuse. You want to make sure that all of these connections are nice and tight on this DC bus bar distribution. And you can see the various different color-coded wires back here. These are all various DC circuits within the inside and outside of the Alpine. And that would be for things like interior lighting, exterior lighting, furnace power, power up to your air conditioner control modules, and various other fans and things like that you have within inside the Alpine. So we're going to put the cover back on, and hopefully they'll give you a good idea of what you can look at and what to check on your power distribution panel, and how to ohm your shore power cable from one end to the other to make sure that you've got good continuity up to the power center. Okay, I'm going to show you how to measure 120 volts at the power center. And I've set the meter. In my case, I've set the meter to the volt scale, and you can see where I've selected AC volts because that's what we're going to measure. Okay, and you will notice in this picture that the black meter lead is connected in the lower left part of this video. It's connected to the white bus bar, and I have the red meter lead is pressing up against where the hot lead comes in from the back end of the fifth wheel, and we're plugged in, and we're reading 119 volts on one leg of the hot lead coming into the Alpine. Okay, and now we're going to measure the other hot leg of power coming into the Alpine, and again the black meter lead is connected to the neutral bus wire, and that's the big white wire coming in down there. And you can see that my meter lead is touching up against the heavy black lead that feeds into this 50 amp breaker. And we'll come over to the meter and look, and we can see that we have 119 volts on this side also. So what that told us with those two measurements is that we have 120 volts on each leg coming into the power distribution center. You have two 50 amp legs coming in, and so you have a total of 100 amps of available service in the Alpine at 120 volts AC. Well, we're here. I'm going to go ahead and show you how to measure your DC side of your power distribution center. So we've set the meter up to where it says volts DC, and you can see that I have the black lead of the meter is on the white bus bar coming in, And we're going to take the red meter lead and we're going to touch to the very first terminal that's fused on the bus bar, and you can see that we read 13.6 volts DC. And we're going to come down, we'll come down to the middle, and we're going to make connection there. Again, my negative lead of my meter is to the white wires coming in on the bus bar, and the red lead is touching this particular circuit, if I can keep my meter lead on there. And now we'll come over and take a look, and we can see that we have 13.6 volts DC. And we'll do one more test. We'll come down here to the a ways down to another DC outlet feed, and you can see that we have 13.6 volts DC. And the reason we're reading 13.6 volts DC is we're plugged into shore power, and the converter is supplying DC power to the bus bar, and so that's why we're reading 13.6. This also tells me the batteries are in good shape, and the converter is working at a nominal voltage of 13.6 volts. So if you think you have a converter problem, you can also make the measurements right here at the power center or at the battery to verify that your converter is actually working like it should. You should see a nominal voltage of 13.4 to 13.8 volts when plugged into shore power.